Distribution of the sample mean. First of all, looking at if the underlying population is normally distributed. So we use x bar to denote the mean of x, and also the distribution of the sample mean is sometimes called the sampling distribution of the mean. They both mean the same thing. And where this comes from is if we've got a random sample of n values, so x1, x2 all the way up to xn, and that's taken with replacement from a population with mean mu and variance sigma squared. So you've got the overall population, and of that you're sampling n values. And our population is distributed normally with mean mu and variance sigma squared. This then leads to x bar being the distribution of the sample means, and where x bar is 1 over n of all of your values added up. So how you normally find the mean, from the sum of all your data values divided by how many you've got, which is n. Looking at this, looking at E of x bar, we can expand that into the expectation of what x bar is equal to, so 1 over n times x1 plus x2 all the way up to plus xn. And then using our linear combination knowledge, we know that 1 over n is just a number, so we know that E of ax is equal to a E of x, so we can pull out the 1 over n, and then we get E of x1 plus x2 plus all the way up to plus xn. Because we've taken these out and we've used with replacement, each of these values is independent of the other. So E of all of this can be split up into E of x1 plus E of x2 plus all the way up to E of xn. That means because they're all taken, all our x values are taken from the normal distribution with mean mu, each of these is equal to mu. So we've got mu plus all the way up to plus mu for the nth time. So we've got n lots of mu. So overall we've got 1 over n times n mu, so we've got mu. So the expectation, or the mean of the x bar, is mu, which matches the E of x, which is also mu. Doing the same sort of thing for the variance, we know that if we've got the variance of ax plus b, that is equal to the variance of x times a squared. So if x bar is our 1 over n times all of this, then we know that the variance will be this squared times the variance of the bracket. So that's where the 1 over n squared times the var of x1 plus the var of x2 all the way up to the plus the var of xn comes from. So each one of these has the variance sigma squared because it's come from the population with distribution x. So we've got n lots of sigma squared, so we've got 1 over n squared times n lots of sigma squared, so we end up with sigma squared over n. So the variance of x bar is sigma squared over n. This then gives us the distribution of x bar being normal with mean mu and variance sigma squared over n. So if you're taking the sample mean from an underlying normal distribution, it links to the underlying distribution by the mean will be the same and the variance will be just sigma squared over however many data values you're taking the sample of, however big your n is.